There we go. We're live.
Hey everyone, I guess we'll wait a minute or so if people are attending.
Yeah, hey all, welcome. Keen for this one. I think this weekend should be good fun.
Cool. I guess we'll start. Thanks for joining everyone. And yeah, it's a very exciting webinar and initiative we have for Web3 and our blockchain development program. And we're pleased to be partners with Cudos, a new exciting layer one, which is taking an innovative approach due to the decentralized cloud computing. But I guess Ollie, we're joined with Ollie today, who go over everything on Cudos and Web3, and he's part of the DevRel team. And we're also going to be joined by Antrix, who's joining on later on to give everyone the sort of spiel on. He's joined already. Hey, Antrix.
Hi.
Yeah. So guys, if you want to introduce yourselves, that'll be great, and then you can carry on the presentation, Ollie.
Yeah, absolutely. Thanks so much, Ram. It's really cool to be here. We're stoked to be one of the platinum sponsors of Showcode's Athena program, and yeah, we're excited to also be the sort of representatives of Web3 amongst all of the companies there. We like to think we're kind of forward thinking in terms of this Web3 world that we're going into. But yeah, so on my side, I'm Ollie. I am the DevRel lead, so developer relations lead at Cudos. And so my job is, my day-to-day is just sort of having fun chatting to engineers and being that point of contact between the engineers out in the open and the company itself, so that we can build it out the best way for developers. There's a QR code on the screen at the moment as well. If any of you want to scan that, that's my link tree to my own personal contacts. So if you want to jump on and reach out there. It's also got a link to it right at the top for some dev resources and the Athena hackathon. We've got our own channel on our Discord, which you'll be able to get to there, which if you want any additional questions or any additional support during the whole weekend, we can also help there and get those questions to some of those team members who won't be able to make it in person as well. But yeah, I'll let Antrix also introduce himself quick, and then we'll roll with my side.
Hi, my name is Antrix Verma, and I'm from India. I'm a developer ambassador for Cudos, and I focus on curating content and managing developer-related software questions on how to build and deploy on the Cudos blockchain. And I'm excited for this session that we're having.
Nice one. Yeah, so good of you to join us as well, Antrix. I know I value it hugely, and I'm sure a lot of participants will as well. But yeah, let's have a look here. So we're going to start off with what is Web3, and let's go back through the history of the web briefly. Web 1 was this idea in sort of the 90s of this read-only web. So it was a lot of large entities with big servers that were able to distribute their content for a lot of the general public to be able to consume. So think of like big news outlets or things like that. But Web 2 came around in the early noughties, and it was characterized by social media. And it was our ability to interact with the web as a user and create content ourselves. And that's where things like social media and YouTube took off, where anyone could become the content creator. So it gave rise to this read and write web. But now Web 3 takes those two characteristics one step further, and it goes to read, write, and own. And this is thanks to a lot of the underlying technology in terms of distributed databases. those distributed databases usually being in the form of blockchain networks. And that allows you to uniquely represent assets or anything of value or any content that you might create globally across a distributed network that is an agreed upon source of truth. And it's given rise to incredible innovations already in terms of musicians being able to own the work that they create, and tracking of various assets in sort of conflict areas, or being able to also trade assets that haven't been tradable before. So there's a lot of interesting stuff happening in that Web3 space with cryptocurrencies, which you would have heard of, and NFTs, and exciting things that also bring a lot of true utility and an ability to actually use the platform for good. And that's down to that word own as well. It brings about this ownership economy that we get to truly own the stuff that we're creating in this new generation of the web. So it also takes us to what is a decentralized application, because that's the important aspect of being able to join the Web3 revolution, is to actually have these applications built on it. So that's called a dApp or a dApp, depending on who you are. So a decentralized application, or dApp, is an application built on a decentralized network that combines a smart contract and a front-end user interface. And that smart contract side there is also very important. So for those of you who haven't had much of an intro to smart contracts before, you can think of them actually, the name is a pretty good giveaway as to what they are. They are a contract, as you would write between any parties, between a mortgage lender or signing a lease on a house. But they are intelligent because they happen to be written in code. And so that code gives them the ability to act based on a set number of conditions and act autonomously or automatically based on when those conditions become true. And so that gives rise to this whole new world of being able to decentralize things away from any one entity having to sign these specific contracts in person, but we can rather let the code do the work of making those contractual obligations. And this enables a lot of things on that ownership front. And so the transfer of ownership can be represented in those contracts, and we can write those contracts so that we can fully trust these networks to act on in a completely deterministic way. So we can see there a little bit of added text here. There, a dApp has its backend code running on a decentralized peer-to-peer network, like a blockchain. Contrast this with an app where the backend code is running on centralized servers. So you're often familiar with say the apps on your smartphone, where underlying there is a central database owned by some entity that is associated with that application. And that one entity is running that server and that database for all of the users of that application. But this decentralized idea is that that database is now being run as a global network. And so there's no centralized authority on the ownership of that database. And so it allows the world to agree on what happens on that database on a far broader scale. So also let's have a look at what is Cudos. So this is the part where obviously we're interested in, and the core of Cudos is our two sort of distinct products, but they're also melding into one at the same time at the moment. And so you can look at it as two different things here. The Cudos blockchain, so we have our own one of those distributed databases, and that is the blockchain itself. It has smart contracts enabled on it, so you can write these contracts, self-executing contracts, in order to represent ownership, in order to do all of the things we were talking about in terms of transferring assets and representing value. But things also get interesting with the other side, and that's our Cudo compute network. And that's why we've actually built the blockchain, is to facilitate the compute network. And what it is it's a distributed network of computing power in a cloud sense. So you would have probably heard of things like Amazon Web Services or Google Cloud Platform or Microsoft Azure. Those are the traditional centralized cloud services. What we're doing is effectively an Airbnb, but for computing power, where anyone can actually contribute their computing power to this network, and it can be rented out to any demand-based users on the network as well. So at the moment, we've got a few large data center providers, but we're ultimately going to go to smaller and smaller devices. And our end goal is to have the compute platform where people can earn from sharing the extra resource they might have on mobile phones or games consoles. And it allows us to tap into the idle computing power that is available across the world, where most of it is idle or unused. And this is incredibly important to be able to use technology that is sitting unused. So a lot of these data centers are spending incredible amounts of money, energy, and actually an incredible amount of water just running the data centers to provide access to cloud services. But if we can use the devices that we all already own, and you can get paid for those types of things, we're now combating a lot of different issues in terms of e-waste, in terms of sustainability of energy, and in terms of that water use as well. Quick fact for you, California alone, just that one state uses 185,000 Olympic swimming pools of water a year just to cool its data centers. So imagine if that could be distributed across our cell phones when they reach 100% charge at night, or our gaming consoles, things like that.
One thing,
Rom.
One thing that came up from Camille is, are there any slides? It seems like you're
oh no,
and it hasn't been shown.
Oh gosh, yeah. So there are slides, and I've been talking to these slides.
So, there we go.
There we go. Well, I can run back through some of the slides here, so you can just see what they look like. So there was a QR code on the front one, which will be on the last slide as well if you do want to scan it. I'll just keep talking for a few more seconds while you get your phones out. But it's also on the last slide there. And then, so I just had three distinct images for Web 1, Web 2, and Web 3. And that one wasn't particularly interesting. I did that one quickly before this call. But here we can sort of see the Cudos blockchain and the Cudo compute platform sort of side by side. So we've got some smart contract code there. That allows for the smart contract side of the blockchain, but then we've also got the Cudo compute interface, and we've also got some exciting news for you. All of the Athena participants at the hackathon, whether you are part of the Cudos track or not, whether you choose our topic or not, will get to use Cudo Compute for the duration of the hackathon for free. So if you are deploying any of your work onto, and you need a cloud instance for that, so a virtual machine, you can chat to me at the event itself, and we will get you set up with a Cudo Compute account and get you set up with a secure shell to be able to access that unit of computing power. So I think that's pretty neat. And we only got that sorted this morning, so I'm pretty excited. But now let's actually jump to a little bit on the Rust programming language. So it happens to be the world's most loved programming language, and that's actually for the 6th year in a row. It's my favorite programming language, and there's a lot of really cool benefits to it. And I think it's going to be genuinely, in my opinion, is going to be one of the important technologies for the next 10, 20 years in terms of programming languages. So you can see that around 87% of people absolutely love Rust, and that's from the Stack Overflow survey last year, from 83,000 odd responses. And yeah, it is truly a beautiful language. So let's have a look at some of the things that make Rust a pretty cool language. It's incredibly high performance, while very importantly, it ensures an incredible amount of memory safety. This is an incredibly important side of keeping your code secure, preventing memory leaks, preventing hacks, and making sure that things work in a purely and completely deterministic way. Rust has an incredible way of handling this using ownership, which is a topic you'd get to know about if you dig in a little on Rust. But it means that we don't need a garbage collector for the language either. And that's also what makes it incredibly fast, and it can be installed on pretty much any device, from embedded tiny little hardware all the way to the largest of video game engines and incredibly powerful platforms. It's got great support for concurrent programming. So if you need to optimize with multiprocessing, you can do that in Rust. Also owing to its incredible performance, one of the fastest languages around. And what is actually a very interesting thing about these high performance languages is that they make the world a lot more sustainable as well. When we're talking just running code on our own machine, it doesn't matter too much if we were to run our code in, say, Rust or Python. But when you are on a global level and everyone is writing code in a specific language, all of those languages do have to be run on different systems. And running a more efficient language is incredibly much more performant and more sustainable and easy to run with less computing power on a global scale. And I think it was something like Rust is I think it was 100 times more sustainable to simply run than some of the other languages that are out there and that are garbage collected languages. So using a language fast and that's fast gives you all of those benefits, as well as that really cool sustainability angle. There's also a growing number of Rust packages that make the open source development of the project amazing, and things that you can call in order to get things built and use other people's libraries and code from the crates.io repository. And it's got a vibrant community driving the development of the language. So it's a really wholesome community. I should have actually added a picture, but they've got this cute little mascot called Ferris. Ferris, because Fe is iron and iron rusts. I think it's pretty clever, but I'm a bit nerdy. And it's got backwards compatibility and stability ensured. And that's really useful because it compiles down to a binary. And so those binaries work on an incredible number of devices, backwards compatible. Let's actually just have a look at my Twitter account for a moment. I happened to tweet these, I think it was last week, retweet these all in a row, and purely by chance that I retweeted these 3 in a row. You can see what the Twitter algorithm is doing for me, but let's see. So Teddy Knox says, knowing Rust feels like a superpower, which I completely agree with. Mark Russinovich, who happens to be the CTO of Microsoft Azure, said, speaking of languages, it's time to halt starting any new projects in C or C++ and use Rust for those scenarios where a non-garbage collected language is required. For the sake of security and reliability, the industry should declare those languages as deprecated, which I find to be an incredibly bold statement, especially from the CTO of Microsoft Azure. So that's a pretty impressive feather in Rust's cap. Then we see Shane.stars here. Not to mention, building in Cosmosm is faster than Solidity. Fewer things can go wrong. Don't need to drop down to assembly for performance. At some point, app layer innovation may happen in Cosmos first. Still a year behind Ethereum, though. So that actually doesn't mention Rust itself, but it does mention 2 of the smart contract languages, Cosmosm and Solidity there. Solidity, a lot of people may know from the world of Ethereum, but Cosmosm is the world of the Cosmos ecosystem. And it is a Rust-written smart contract language for all of the blockchains, or almost all of the blockchains within the umbrella of the Cosmos ecosystem. And importantly there, Cudos is one of those blockchains within Cosmos. So you will use Rust and CosmWasm in order to develop these smart contracts for representing ownership within the Cosmos ecosystem and on Cudos as well. And that's what Antrix will actually dig into a little bit after me here. But a dApp isn't just the smart contract. The front end is also an important for the user experience. So here we have a front end of the Osmosis decentralized exchange. So you can see this is a way of swapping cryptocurrency, and you can actually swap for the Cudos token there shown on the screen. Importantly, we can't just have these smart contracts that are operating as this sort of core code without like a neat user interface to make it into an app, or in this case, a dApp. And that's where some of the importance around this ecosystem is really crucial. And so what we're going to do now very quickly is I'm going to show you how easy it is to get yourself going in terms of that app front end connecting with an underlying blockchain. So here is the QR code again, if you want to scan that, if you want to join the Discord. So I'm hoping the link to the Discord works correctly. Otherwise, just message me. I'm Kudo Ollie on the group. I should be online at the moment, but we'll get you added to that Athena Hackathon channel on the Cudos Discord server, where we can also support. And there's also some dev resources that I'm going to be updating after this as well. But you can get to the samples repo of GitHub of different Cudos samples with some useful dev resources there as well. So hoping those of you who wanted to scan have done the scanning. And so with that, let's drop to a terminal and let's see how easy it is to actually get things going. In terms of a dApp running on localhost with a very neat tool called Create Cosmos App. And so what it is it's an NPM package. So you'll need Node installed on your machine. And you just install it through NPM. And it's literally as simple as typing Create Cosmos App. We get to create our name for the app. So let's call it Athena Demo. And we can see that as things go here, it's now asking us, do we want to connect a specific chain or connect to multi-chains? I'm going to connect to multi-chain. And you can see that the project's been created, and it actually gives us the next step as to what we need to do to get this going. So this will take a little moment as it's pulling down a lot of files and compiling the project itself, but it's getting our front end going. And what makes that front end important is it has this Web3 layer where it can connect to underlying blockchains. And so for those of you who haven't connected to a blockchain before or haven't used a blockchain before, a lot of that interaction happens through what's called a wallet. And that wallet provides an injection into the code on a web page that allows you to interact using your private key to sign transactions on your behalf. And so we'll see in a moment when this all compiles how that'll actually work. So basically, this is just a bare bones connection to a wallet, and it is a 2-command activity that gets you going incredibly quickly. From my experience with hackathons, being able to get going really quickly is hugely important to being able to have something really, really cool to show by the end of the 24 hours. So we can see here that the web server has started and it's available on localhost 3000. And so if we run here, we can see it doing things on the right-hand side, and we are loading up from our local server here. What's cool here is that we can actually choose any of the chains within the Cosmos ecosystem, but naturally I'm going to choose the Cudos chain here. And now it asks us to actually select our wallet that we're going to use. So I'm just going to use the Kepler extension. And what that's done is it's actually connected to this little K extension that I have installed on my machine here, and that's my wallet. And so you can see that it has read my address from that wallet, and I am now connected to the Cudos blockchain and can start doing interactions with the underlying network. But yeah, so that's the demo of how easy it is to get going with a front end. So this you can see is done with Cosmos Kit and Next.js. Cosmos Kit is also part of CosmWasm, or CosmJS rather, and so those are the front end tools that get all of this going. And we're happy to show you at the hackathon itself how some of those additional bits work. But I'm also going to take this chance to hand over to Antrich, who is going to show you the actual smart contract side of building on blockchains and being able to contractually write something that is verified on a blockchain. So not actually too sure how to hand over the control here, but I'm going to stop sharing my screen for one.
Hi.
Hey, Antrich.
Hi. So when we talk about, essentially, I just want to give a brief introduction to what is Cosmosm. So Cosmosm is sort of this framework that allows you to build smart contracts, as rightly said by Ollie. It is it's a method of building those smart contracts. Now, as some of you may know, smart contracts are usually built using Solidity on Ethereum. At least that's the first programmable cryptocurrency, the first blockchain that allows you to build applications on top of it. So Cosmosm is a new way to build those smart contracts with similar logic and similar security, but in a new way. And CosmWasm relies on Rust, because Rust is, as Ollie has rightly put, a fast and performant language. It's robust. It has great security features. Therefore, Rust is the language of choice for CosmWasm. So I'll just share my screen so that I'll share my entire screen. Yeah. So here, if I go back to the Cosmosm documentation, docs.cosmosm.com, here you'll see that it talks a bit about what is Cosmosm. It talks about the use of Rust and future possibilities. It also talks about how to actually use it, and it gives you a bunch of sections. So what I'm going to do is I'm going to dive into a sample smart contract that I got up and running with this command. So I'll show you. So there's this command called a bunch of commands in my terminal history. Basically, this command. Yeah. So this command right here is something that I use to generate all of this boilerplate code. So similar to the create Cosmosm app that Ollie showed, this command allows you to generate a Cosmosm smart contract template. So it just basically clones this GitHub repo into a separate folder inside your directory. And as you can see, it's a quick start template to get started writing your own Cosmosm smart contracts. With this, you don't actually have to go ahead and write all of these boilerplate files from scratch. So I generated this a few hours ago, and let me show you what this actually does. So if you break down all of these files, the main thing that pops out is contract.rs. All of your source code lives in the source directory where you have contract.rs, which is this file right here. It has 150 lines or so, and this entire file contains the main crux and the main logic of your smart contract. The first thing that pops out is this instantiate function. It's the first public function defined in the file, and it does a few. It's the most important function in my opinion, and it's one of the 3 functions that defines your smart contracts interface. Okay, so what it actually does is this instantiate function allows you to call into the smart contract logic. Think of it as an entry point or a constructor for your smart contract, right? With this instantiate function, you can, as the function's name says it all, you can initialize or instantiate the state of your application, right? So your smart contract would have some way of storing something, right? So similar to Web2, where you have a database where you store something and you have a handle to that database. Similar to that, your database is the entire blockchain, but you have a handle to where you want to store that. And that handle is what we call state, right? You have an in contract state. And this state is what is initialized or instantiated with this function. So here you can see this variable declaration says state is equal to, and it creates a new state that is a new struct state, and it initializes it with these values, and then it saves that state into it saves this variable state into this broader global state. It does a few other things like set the contract version, the contract name, and then it returns a response. But the main thing it does is initialize the state of the contract. Now, the state actually comes from this file, state.rs. It's another very important file that you will deal with most of the times when you're building your smart contracts. And you essentially define a new struct, which is state. You add in a few things like a few fields like pub count, pub owner. This default contract has the count and owner. You could do something like pub favorite number, and you could say I32, not I31, I32. Then I32, if you know Rust, you know it's a 32-bit signed integer. The I represents integer, and this right here, ADDR is a different thing though. It's something that comes from the Cosmosm standard library, and as the annotation says, it's a human readable address. So similar to the hexadecimal addresses you have, like 0x000ff, something like this that you have in Solidity, where you have a hexadecimal address. In Cosmos, you have something called BEC32, which is a different standard of encoding. And so all the addresses that you'd have, for instance, your own account, would be in BEC32. So it says that in Cosmos, this is a BEC32 encoded address. And just to show you how it looks like, this right here is my BEC32 Cudos address, my testnet address. And it has the first 3, 4, 5 letters actually represent the blockchain it's from, right? So it's if you talk about a Cosmos native blockchain, it's probably going to be Cosmos and then a few random letters and numbers. But in Cudos, it has Cudos written here in the first 4, 5 letters. So that's the difference between how addresses are there in Cosmosm and Ethereum. It's not a big difference because generally you don't manually interact with these. You generally use this ADDR type or some other abstraction. And now this ADDR type is quite powerful in this because you can do a lot of things with it. You can check whether or not it's a valid address. So if for instance in your contract you have a function where you take some input from the user, and that input is a bec32 address, then you want to check whether or not it is in fact this bec32 address. And in order to do that, you can use the you can use this validate function where you can find out whether or not it's checked or not. You can also convert a string to this ADDR type. So if I have this string, I want to convert this string into an ADDR type, right? So I want this input and I want to output an ADDR type that has that the main core address value is the string. So that's mainly about the address type. Then once you have the state, you define another variable which is also state. The difference between these two is that this right here is a value. This state becomes a value, while this variable is a struct, right? It's a struct like in C or Go. And this state variable right here is constant. You cannot change it. All you can do is append to it. And now it gives me an error that it's missing field favorite number. So let's add that. We can add a constant here. Doesn't matter. We can also, and that's about it. Let's convert this to snake case, and let's convert this to snake case. Now, this state is then called in, and we save it in that state. And then we finally return a response. The response returned is OK. OK is a success response, and it contains the success value, which right here is the response that we define here. You can see the function signature for instantiate is always the same. You're always going to have a dips mute, env, message info, and instantiate message. Let us move on to the documentation for Cosmosm, where it talks a bit about messages. Messages are probably the most fundamental unit of each function in Cosmosm. As you'll see, execute also has a message, then query also has a query message. So all of these things have messages, right? And messages is the way you interact in Cosmosm, right? If you look inside, there will be a message.rs that defines messages. And as we do, we have a message.rs that has several different messages. It has an instantiate message, execute message, query message, get count response message, which is it's not a message, it's a response though. So the messages are basically how in Web 2 you have an API, or rather a REST API, and the REST API has some JSON, right? It would have some JSON like username, right? And we have something like Bob, and it sends this JSON data to the backend, to the server side, right? And so the server would consume this, and it would process and return a response like 200 status code, right? So if I have that REST API, it would do sort of, this is the typical way Web 2 would work. And this JSON data, that is username Bob, is essentially what messages are in Web 3, right? Or rather in Cosmosm. because those messages are the way we interact with the contract, the data that we send, the information, right? Not exactly the data, but the information, right? So if we take a look at the examples of messages, we'll come here and let's come to execute. Now, execute function is another entry point. This execute function is run when this execute function is run when you want to mutate the state or the current situation of the smart contract. So for example, as you can see, again, the function signature is the same as this function signature, except instead of instantiate message, we have execute message, because the type of the messages are different. You can see instantiate message is this and execute message is this, right? And then we match the message, right? We use pattern match, which is a common language technique. So we pattern match the messages that we receive, and once we match the message, we then check whether it's this message or it's this message, and based on that, we conditionally execute different functions. So in our case, we have the execute message, which is this message right here, which we get as the argument, and we check whether or not it's increment, and if this message is increment, we run this. So it's similar to the Web2 example that I gave right here, where someone tells us that in some JSON data, someone tells us that something like message increment, right? And basically we're getting that into our REST API, right? So that's the input, that's the JSON data input to our REST API, and based on that, we conditionally do some sort of processing, which in this case is running this function. So we can also see that here it's really just an enumeration. All of these messages are enumerations, and we check if it's increment or it's reset. We add the different values. In case of increment, we don't have any. So this right here is also a struct in its own way. So increment is a struct. I think it's an unnamed struct, I know. So this struct then takes, for instance, this reset struct has one field, which is count, and this field right here becomes what we call the data. So it's something like this. So this is how the typical processing would look like. So this data would be count and some number 32. So this is how the input to a smart contract would actually look like, right? So this reset right here, this reset message would be the equivalent of this in Web2, in a server side or a backend application that you might be building. So it's essentially the message and the message data is essentially an input. So again, we just do some pattern match, we get the reset, we get the count, and then we pass this count that we get, and we pass it into the reset function. Now these both functions are defined exactly below the execute function, and then we have increment and we have reset. All they do is they update the state. We pass in depths mute, which is our dependencies. We pass in the storage, the action, and this action right here is a lambda function. So we just pass in another function to action. You can read the annotation. It says that loads the data, performs a specified action, and stores the result in the database, which in our case is the state or the application state. And once we update it, this update function though is very, very useful. It's very handy. It's something you'll deal most of the time, because whenever you want to change anything, you're using update. If you want to increment the value of state, you use update. If you want to set the value of the state to something entirely new, you still use update. And then That's about it for execute. Then we have query. I'll just check the chat for the moment. Yeah, okay, it's fine. So in the chat right here, the next thing that we have is query. Query right here, we again have a special query message, and we have we check whether it's this get count message, and in that case we use this toBinary function which converts which takes in a function. So this function takes in a generic function, and the data and whatever this function returns is converted to binary, and then it's returned from the contract. So all of this code is all well and good, but let's actually see it in practice, see a practical understanding of it. So the first thing you do when you start to interact with Cosmosm or the Cudos blockchain is you first need to get an address. You need to get your own account. I think Ollie talked a bit about accounts. So here I am on the dashboard.testnet.cudos.org. This is something that you will need if you want to interact. I've just added the link here. If you want to interact with, if you actually want to build on Cudos, this is something you'll need. The first thing that you do is install the Kepler wallet. It is the wallet for, I think it's only available for Google Chrome. It's an extension, and it's a wallet for the interblockchain ecosystem, or rather just the Cosmos ecosystem. So once you install the Kepler wallet, all you do is you're prompted to create an account. You just add account, create new account, add an account name, and just do next. Once you've created an account, you can open up dashboard.cudos.org like so, and you just hit connect Kepler wallet. And once you do that, it'll prompt you to add in this right here. It'll prompt you to add the Cudos testnet public v3 chain, right? So the Cudos testnet, the Cudos testnet chain. So there's one Cudos mainnet and testnet. You'll be developing on the testnet, at least for the duration of the hackathon. And once you do so, it'll show you that you have 0 tokens available here, but in order to actually deploy your contract on the blockchain, you need some tokens, you need some money, so to say. And the way you can get some tokens is by going to the faucet, which is this icon below, and you just input in, you just copy your address from here, which in my case is Bob. I already have some 11 Cudos tokens, but you can have, I don't know, you can take a maximum of 100. I'm going to take 2 more. You hit receive tokens. It tells you that the transaction was successfully executed. It takes, this is also something that I did 10 hours ago. I got 5 Cudos tokens for the same address. So it just takes a few moments, and it shows up here, 13 Cudos tokens. Now, one common question would be, how many Cudos tokens do you actually need to execute one interaction with the smart contract? So once you have a sample contract up and ready, what you're going to want to do is you're going to want to go to wait, let me go into my working contract. So this is a Cudos name service example contract. So I'll show you. As you can see, I have this Cudos name service WASM binary already compiled. If you actually want to go ahead and compile your own binary for your own contract, the way you do that is you use something called so this is the GitHub repository for that. You use this command. You use this thing called Rust Optimizer. Rust Optimizer is this tool by the Cosmosm team that allows you to deterministically produce smallest possible WASM for your Rust contract. In production, the CosmWasm team recommends you to use and optimize your smart contracts using Rust Optimizer. And so, in order for you to actually compile a binary, you're gonna have to do this. Since I'm on ARM64 Mac, M1 Mac, I'm just gonna use Rust Optimizer ARM64. In order to install this image, you just click on this version area right here, this tag, and you just copy this and you just Docker pull it. It works. As you can see, it says done. I was successfully compiled this binary. Now, furthermore, there is a file called InstructionsMD. It's a markdown file that has all the steps to deploy your own smart contract. Now, Cosmosm, in order to deploy it on any Cosmos chain, you're going to have to do some work in that you're going to have to run multiple commands and do multiple steps. So this file shows you all the steps. So the first thing you do is you upload the WASM binary on the blockchain. You basically take the WASM binary and you put it on the blockchain. That's all you do. To do that, you're gonna use this first command, right? As is equal to. All the things in angle brackets and all these commands are things where you have to put your own information. So in this case, you put your own account name or your own address. In my case, I can just do this and I can wait. I can use the Bob address. So if you follow the earlier steps where you created an address, where you create an account and you use the faucet to get some tokens, then you should be good to go. And now what we are essentially doing in this command is we are running this whole, so all of this is just one command, and we store the result of this in a variable called res, which is short for result. This comes directly from the Cosmosm documentation. We then set a node, which is the blockchain node that's actually the Sentry node that's actually running the Cudos blockchain, which is the testnet Cudos Sentry node that is given to us by the team from Cudos. Then we provide the chain ID. Now this address has to be the one which has the tokens on this chain. So if I come back here, Cudos dashboard, you see that it shows Cudos testnet public v3 version 3. So as long as it shows this and you have set your chain ID to this, you are good to go. Everything's good. Then these are some things that you just have to do. --gas just says that the gas will be automatically managed. You don't have to care about that. The gas price is this many Cudos. A Cudos, sorry, it's not Cudos. It's this much A Cudos, and the gas adjustment is 1.8. You don't need to worry about all the gas parts except this. So I asked you earlier, so I told you earlier that how many Cudos tokens would you need for this one interaction. So in order to upload your WASM binary on that, when we essentially do gas prices this much, we tell the Cudos blockchain that this is how much money we're willing to give you to upload it on the blockchain. So just the difference, the conversion rate between A Cudos and Cudos is 10 to the power 18. That means if I have these many A Cudos tokens, if I divide that by 10 to the power 18, I need 0.000005 Cudos tokens in order to upload my WASM binary. So with Cudos, the gas fees, so this is the gas fees only. So the gas fees is very low, and it's really good for people who want to continuously test and deploy their applications on Cudos. So even one Cudos tokens in testnet suffices. So when we do this, the file right here is different. This is a different artifact file. So we essentially just do .wasm from. I'll just go back. It's a long command, but basically that Cudos name service app.wasm is a different wasm binary. The wasm binary we need is Cudos name service. Okay, it's this one. Sorry. So there's this arch64. So if you're using Rust optimizer, the non-ARM64 version, then it will not give you this arch64 right there. But since I am on an ARM device, I have to add the arch64. So my resulting binary looks like this. So it has a suffix of arch64. Wait a minute. I'll use boss, which is an account name that I had earlier. It's going to take some time. It shows you the gas estimate. I believe this is the amount of Cudos tokens. And when we echo res, now it didn't really give me anything other than this. That's because it stored the result of this variable into res. So if we echo res, you can see that it's some JSON mess. So I'm just gonna come here and I'm gonna go to a prettifier JSON, and I'm gonna use JSON formatter. And if you make pretty, you can see that it makes a lot more sense. It gives me the height at which basically the block index, the data, which is, I believe, some sort of WASM binary data, different attributes, the type of message, the different attributes. So these are events, and the gas used and the gas wanted. So the gas used was this much, gas wanted was this much. So and then it gives me a bunch of other events that we don't really care about, not for the majority of the part of this. What we actually care about is, if you come back here, it says we get the code ID from the previous command. So all we care about is the code ID. And we'll see why that's useful. So as you can see, if I do echo code underscore ID, it's 54, which is basically this right here. But all we've done is I've used JQ, which is, I think, JSON query process tool. If you don't have it, you need to install JQ. It helps you in formatting and processing JSON inputs. That's what the Cosmosm team recommends using. Then once we get the code ID into this separate variable, we can simply instantiate the smart contract on the blockchain. So till now, all we have done is uploaded the WASM binary. Now we actually need to go ahead and install it and initialize it, instantiate it. But actually, this instantiate term, it seems quite familiar, probably because we have an instantiate function here as well. That's because when we instantiate the smart contract on the blockchain, we are basically just running this function, which initializes and instantiates the state. And that is what we do when we instantiate the smart contract on the blockchain. So once we do that, we go ahead and just copy this piece by piece. Add in my account name. Now label is just some name that you need for it. Label in our case, we don't really care about that. It can be anything. I just named it Cudos Name Service App. The node, the chain ID, and again the gas prices and the node and the chain ID. All of that is the same. It gives us a gas estimate, and again it returns us some JSON mess. Now the first thing in this command, now let's break this command down. We use something called TransactionWasm instantiate. So whenever you interact with the blockchain on any Cosmos blockchain, you use something called TX, which is transaction. Transactions are basically read-write operations, not read but write operations, mutate operations. And if I go back, if I show you TX, it gives us a bunch of available subcommands like admin, bank, broadcast, and each of them have different, you can see their different purpose. IBC transaction, IBC fungible token transfer, crisis transaction, bank, right? So with this, when you do TX-WASM, you'll see that it has even more subcommands. So all of these really are what you call modules in Cosmosm. So WASM is a module, NFT is a module, Gravity, admin, bank, all of these are different modules. And so in this WASM module, and we do this instantiate. We instantiate a new WASM contract. This instantiate takes in a code ID, which is 54 for us. So it's the same thing as manually typing in 54. And then we add in this init, which if you remember is this. So we just create a new variable init, which was just this empty JSON. So I'll show you. Init right here is, I think it's this message. So if I go back to at least this smart contract, the Cudos name server smart contract, which we are initializing, you'll see that in instantiate, we really don't do anything with the state because we don't instantiate the state in this situation when we instantiate it. Therefore, we really just pass nothing. So this init is the init message, the initial state of the application. So if we were dealing with something like this smart contract itself, we would do something like this. We would have count 34, right? Message.count. And we would then initialize it by just doing that. And then we would finally pass it in while we're instantiating it. But in our case, we're not doing that. Now this JSON mess right here, we don't care about it yet. What we want to do next is we want to get the contract address. Getting the contract address, we basically run this command, which in itself is a mixture of different commands. So first we run this. The output of this is then piped into JQ, which then gets a value, which is then processed. So we basically just remove a bunch of carriage sequences, escape sequences and all. And we save all of that into this contract, which again, if I echo that, is just this. So this is similar to a contract you would have on Ethereum. So it would look something like this all the way to something like this. So that would be something on Ethereum. That would be your smart contract on Ethereum. But we have a bec32 address, which is your smart contract on the Cudos blockchain or the Cosmos blockchain. So now that you have finally deployed it, you want to go one step ahead and you'd want to interact with your smart contract. Now the way that works is you use this thing called Cudos node. You use this command, Cudos node txwasm execute. Now before I go ahead with this, I want to comment on front end. So as Ollie rightly talked about, front ends and the connection between the smart contract and what the user sees, the user clients end. You typically do all of your transaction reads and writes on that front end. You wouldn't do that through the terminal using a bunch of terminal commands, right? So when you'd use something like create Cosmos app, you're gonna see how you can actually use the front end and use that front end to actually execute it. But again, while you test your smart contract, it would be more convenient for you to use this command and to use the CLI. So I'm just going to copy this command and break it down. So break it down. So again, we do txwasm execute. Execute is a subcommand under the wasm module. We do that with the contract, which is the contract address, which is this one. And then we use this thing called exec, which is a variable that we haven't created yet. So we're going to create it. This Cudos name service contract, if I go back here, come here, you'll see the execute message create domain. So I think the way it works is you do this. Okay, so this exec right here is the message, and then
and Trish, I think your microphone unplugged or something.
Can you hear me? Hello. Can you hear me?
I can hear you, but there's a lot of noise on the line. All of a sudden.
Okay. I'm not sure.
Or could it be Rom? Are you muted? Aha, it's gone. Oh, but now you're muted, Antrix, yeah.
Oh, yeah. Can you hear me?
No, it does seem to be on your side, Antrix. I don't know if your microphone may have come unplugged or something.
Yes, it's on your side, Antrix.
We can hear you, but there's a lot of feedback that just all of a sudden came in.
There we go.
Is it fine now?
That's better. There we go.
Okay. So, as I was saying, this exec right here is, again, it's a message. As we talked about messages, they're ways that you talk about, that you interact with your contracts. It's just at its core data. Now, I said that message looks something like this. It doesn't though. In actuality, so I'm just going to create a sample file. So the way a message actually looks is something like this. You have something like your message type, and then you have all the data right here. So it'll be something like a message field that you have, and that would have a message value. So in the context of this name service that I have here, you can see that under execute message we have create domain. So the message type is create domain, which is an enumeration, which is a value under this enumeration. So you'd really just have create underscore domain. Again, this right here is, I think, Pascal case, but capitalized. But when you actually convert that to JSON, that's converted into snake case. So you'd have something like name, which would be some random name, something like Antrix, Antariksh. You'd have something like, then you'd have TTL, which is time to live. That would be a U8, an unsigned 8-bit integer, something like 56. And you'd have an ID, which would be 0. And that would be how your message would look like, especially at least in this context. So if we are to work with, if we are to create a domain using this name service contract, we can basically just use this create domain function. We can use this message as a string, this message JSON as a string, and finally really just pass it in this. So I can again use this pass, and I can do this. It gives me a gas estimate, and finally it gives me some JSON mess. Again, we don't care about this, right? It's successful. That's because because I have all this JSON mess. I know that the response, it's a successful response. So now that I think this, if you've followed along till now, then it's time to clap for yourself, because you've successfully deployed a smart contract. You have interacted and executed your own message, your own interaction with the smart contract. The only thing pending is query, or what we call read. So we've basically done everything in CRUD, which is create, read, update, delete, except for read, which is what we're going to do now. Now, before I move on to read, I just want to talk a bit about how you would represent this reset message in this sample to-do application that I built, that I generated. So you basically just have reset. You'd also, and then you'd have count, and you just have some random value in count, which would be something like 98, any value, and you would then pipe that into exec right here, and then you'd simply run this command. So you've done all of this on the Cudos blockchain, and really when you run all of this together, it won't take you less than 10 minutes to get started with the blockchain. So the last thing that's pending, if I go back to instructions, the last thing that's pending, so we've done all of these steps, but one thing that would be pending is reading from the blockchain. And you can see reads are called queries in the CosmWasm lingo. So if you come back to query, you'll see it's the other half of the messages. It's basically a database read, or way of querying the state that you have. Now, query also requires messages. If you go back to message.rs, there's another thing here, which is query message, which is an enumeration just as this, and it has its own value. So get count, we can also have something like get all counts, so whatever we want. In the Cudos name service, though, we have a bunch of, I think we have only one query message. Yeah, we have get records, which returns all the domain name records as a JSON encoded number. So this get records is, so if I come back here, you'd get that query message as a message, and it would look the same. It would look like this, except, sorry, I'll just use this. It would look basically like this. So if we were to represent get count as a message, it would look like this. except this would be empty. Because again, this reset has a field count. This reset struct has a field count, but this getCount struct does not. Therefore, you just remove anything within this getCount, and it would be an empty JSON, and you'd have this. So in terms of the so we'll just create a new thing. I'll just create query, and oh my god, I'll just say query, which is a new variable. It's a JSON that has get records. That all it does is it has a key get records, and it has a value of an empty JSON. And again, we snake cased this capitalized get records. That's our query. And I think it would be QueryWasm. So if I look into it, contract state. So if we are to query, I think we'd have to use 3x only. Yeah. So we can do execute a command. I think we can do execute directly, and it wouldn't be execute. Wait. So in order to query something, in order to query something on that, we can, I think let's go on to deployment interaction. So with contract interaction, we basically do query wasm contract state. So I basically do this, and then I would use the contract, and then I would have the query variable and the node and the output, which in our case is query itself. And after that, we would have dash from, we'd have the node, the chain, wait a minute. Let's have dash output JSON. Unknown command. Wait, let's. Oh, okay, yeah. Okay. Okay, yeah. So we need to do this. We need to say contract state, and then we need to add in the smart command, right? So this smart command, which calls the contract with the given address with query data and prints the returned result. And as you can see, it gives me data, it gives me entries, and it gives me a serialized response where it gives me my name, which is antriksh.kudo, the owner, and a bunch of other fields that were automatically initialized when I called the execute function. So that's the basic way you deploy a smart contract and you interact with that smart contract on the Cudos blockchain. In terms of building, so let's try and compile this contract. So what I'm going to do is I'm going to go back to Cudos to do Athena. Just for a moment, I want to see if there are any questions. Everything's good. So I'll just move on to compiling this right here. Again, you use this command, which I'll really just copy it from here. Again, you can get it from Rust Optimizer. This is Rust Optimizer, the non-ARM version. I'm using ARM6. I'm on ARM, so that's the difference. I'll just do ARM64. I'll change the version actually. Even if you change the version or you use a different version, wait, I'll just Docker pull it quickly. It would, yeah, okay, it's the ARM64 version is 0.12.8. We'll just use the latest version, which is 0.12.8. I don't know why it's not working. Anyway, I'll just use 0.12.6. That was the latest version, I believe 3 to 4 months back. Anyway, once you do that, it'll compile Cudos to do Athena binary. And once you do that, you should have an artifacts directory which has Cudos to do Athena arch64.wasm. So if you are to use that, we can, again, I'm just going to go to InstructionsMD and I'll copy this. -- from boss, and I would copy this. I'm getting this error. RPC code failed to execute message index 0, error calling the VM, error during static WASM validation. WASM contract requires unsupported import. Required imports. Wait. It's actually. It's probably due to the environment. Create WASM contract failed, invalid request. Certainly it works. So let me just take a look at this. This anyway, this contract didn't work. With compiling the Cudos name service worked. I know for some reason this isn't working. Probably an issue with the Cosm. Probably an issue with the CW starter pack. This template right here. I don't know. Anyway, once you do that, once you run this this command, it would automatically generate and compile the WASM binary and store it in artifacts. And once you have a ready WASM binary, you can upload it on the blockchain and finally interact with it and use it. Now let's do something with this. So if I'm to, let's say, build a to-do list application, I'd want to change the state. I'd want to change the state such that, let me take a look at this reference code that I had here. So the first thing, so in a to-do list application, the way it works is you have, the way we are building a to-do list application, we have an ID that's connected to each to-do, which itself has a bunch of fields, like the to-do description. It has whether or not it's done, so checked, or rather done or not. And of course, who did the to-do, so the owner of the to-do. So the first thing we do is we import map from CW Storage Plus. Again, just do a new namespace. This would be to do. So what we do here is we create a custom struct, public struct to do. It has a public field of description, which is not this. It's a mutable string or a string slice, and it has an owner address. Rather, instead of that, I think we can we should use a string type. Rust strings are confusing. We should use a global string or a UTF-8 encoded string, and we have a description owner, and we can have something like done, or rather than we can just have done, which would be a bool. Once we have this to do, again we have a pub const state, which is our state, but instead of being an item, it is now a map. Map, as you know, is a mapping, so it maps a key to a value. So it's the same thing as a dictionary in Python, a dictionary or JSON, or really just a key value pair, series of key value pairs. Now map is also a complex type, a storage type. Therefore, it's coming from this CW Storage Plus library. And this is really the only state we require in our application. And because of that, we broke a lot of things in our code here. So let's say when we instantiate something, I don't want to actually instantiate the state variable, because really I don't need to. And then we don't need to add that attribute. Rather, we don't need to do that. We can just simply do this. And because message now is unused, we can just do underscore, and that way it marks that it's unused. Now in execute, we want to change these messages, so I would come here in execute message. The first message we need is create to do. So the way you think about your application in terms of messages would be the different types of interactions you want within your smart contract. So one would be create to do, the other can be update, or rather delete to do, update to do. I'm not going to implement those, so we're just going to have create to do, at least for now. Create to do, it's an enumeration, the value within an enumeration. Create to do itself takes in a few things. It takes in a description, which is, as we know, it's a string. It takes in a done, which is a bool. But since we are creating a to do, the done would obviously be marked as false. So we just add in description. And we pass in the description here. And we change this increment to create, to try, create, to do. Adding try before the name of the function is that's the nomenclature that Cosmosm uses. So we try create to do. The reason it's try is because we try it, and if you have an error, we just return the error. So we just try to do something, and then we update. What we do rather is we do this. We come here, we do let to do, not this, let to do equals to do. Let's just add a semicolon there first. And now tells us we need to import to do first. Once we import that, you'll see it says missing structure fields. So we first add description. We're getting description right here. String, we'll just description like so. We'd have it done, which would be false, because when we create it to do, it would obviously not be done initially. And the owner would be, I think the owner would be, we'd have to pass in the environment. The owner would be, no wait, the owner would be the message.sender. So it's message.sender. So I think we need to pass in the message as well. Or rather, we can just pass in the owner directly, which is an address, which comes from here. So we have in message.sender. And so that way is, that says no field sender on execute message. I think that would be the environment. Yeah, so it's info.sender actually. So info is the message info, which we have right here. So if we do info.sender, not message.sender, and we directly just add owner, and finally done false, it says we need to import ADDR as well, the type, and we finally just do state.save. Now another thing here is we require an ID, which, so as I said earlier, okay, as I said earlier, we require ID, which is basically the key in the key value pair in our map. So I'll add that to the message. That way is when we save it, we require self-stores. I think we need to give a pointer to storage. Yeah, okay, we don't need to give a pointer to that. We simply need to give depths.storage. We save it, and then the key, which in our case is ID, and it's the to do. Okay, so we need to give a pointer to do. And finally, action is create to do. We add the attribute of action to be create to do from increment, and that is our create to do function. Now reset, we don't need a reset, at least not now. Finally, when we query it, we want to get the, now we can actually remove this module. We don't need a module here. So I've got something here. Again, now when we actually, now querying a map is quite complex. It's relatively complex. So I'll refer back to this code that I have. So what we do here is we define a custom struct for each query response. It's basically this thing, but it's a bit more complex. Essentially, we have, the way it works is the way it looks like is we have, when we return all of our to-dos, they look like this. They look like this. Wait. When we return all of our to-dos, they'll look a bit like this. There will be this thing, entries, which would have entries, which would look like this. There's a typo there. Entries, which would look like this, where you would have a description, something like wash dishes. You would have the owner, which would be some address here, vec32 address, and finally would have done, which would be true. And this is basically how your response would look like based on this. So the entry is right here. This entries field corresponds to this entries key, and the value is just a vector, which is essentially it's an array, or it's a growable array in Rust. And each item inside that vector would look like this, which would look essentially like your to-do. So this entry has a description. So all we have to do is describe how this entry looks like. Again, we need to import address, and then we finally do pub owner address. We do pub done, which is a bool. We also import serialize, deserialize. Serialize, deserialize, which are macros that we get from the library crate, which we get from the crate surd, I think. We don't need this, and that's basically it. Yeah. Wait, no. Yeah. Take this like that, and this also. We just tell this. We tell it to. We basically use this macro where we say to rename all of the fields to snake case. Duplicated surd attribute. Okay, yeah, that's already there. That attribute is already applied. So I think all we can do is do this. Yeah, so this works. So essentially, we've now created custom structs for each query response. So for this get count response, we've created these two custom structs. Now, the way we actually do this in a map is we're going to have to get all the values. Let me just take a look at the time. No questions yet. We're running short on time. I'll just wrap it up quickly. So here, what we do is some funny logic here. The reason I'm saying funny, because it's something that you basically wouldn't do ever. So we just say get to dos. Again, we return a standard result, which is okay, which is success. Standard result is basically an enumeration type. This is going to be state. What we do is we take the state and we do dot range, where we apply a few filters. So the filter here is order, which is order ascending. So in the ascending order of items inside our vector, this just gives us a standard result, which has a value of vector, which is basically all the items. So what this does is it gets all the items inside all the to-dos inside our state. Once we get that, we get a mutable response, which is a vec entry. We need to import it first. we create create message. We basically create a mutable variable response, which is short resp, and we just save that. We create a new vector, and we just have an empty vector there, and then we iterate in all of our to-dos that we have, and we push that into we create a new entry, and then we push that into our response. So the way it looks like is this. All the errors are gone. Get. We have a to-do response. We have a to-do response where we have entries, which is resp. So what we do is we iterate for all of the to-dos that we have, and we create a new entry. We add all the fields, give all the fields values, and we push that into this response, which corresponds to this array, to this vector, and we finally get that. We can actually just remove that. It's giving us some errors. Instead of get count response, you can do I think it's to-do response. Yeah. To-do response. Do response. Yeah, helpers, no errors there. And integration tests, we can simply change execute message increment to execute message create to do. Like so. Wait, let me take a look at that. So integration tests, we have, oh, okay. So we don't care about integration tests. Let's try and actually compile it once more. Let's see if it works. Okay, a bit of unresolved and unused imports. So in contrast, the first thing is get count response. There is no get count response. State, there is no state. Apart from that, in state.rs, we have an unused import. So Rust gives us an error on that. Let's try now. Okay, it says you might be missing. Okay. Again, here we forgot to do response. We are returning a standard result which has a to-do response wrapped in it. All of this is the tests module, which I think we can remove. So yeah, I think we can just go ahead and delete all of that. And that should not give us any errors. And now if we try and compile it, it compiles us. It gives us a few warnings which in production we should fix. But apart from that, it has done that. I'll try once more and doing this. If it works, it doesn't. Anyway, it should work. I know, I think it's failing on my machine. But apart from that, this is how you build a smart contract on Cudos and Cosmosm. You basically do all the create, read, update, delete mechanisms, techniques, how it contrasts to Web 2, and the anatomy of a Cudos smart contract. that's all on my side.
Good stuff, Andrich. That was super cool. Yeah, seeing the inner workings of a smart contract like that's really useful, and I think a lot of these participants will, those who are interested on that smart contract engineering, will enjoy also possibly going through the recording of this session as well. Would you be able to add the code of your to-do app to that Cudos examples repo if you get a moment, and then we can get it to.
Yeah, I have the code. All of this, in fact, all the code that I edited that we wrote right now, that is part of that repository only. It's locally. I'll just commit it and push it. Do that. You can add a link here as well.
Yeah, so anyone tuning in or watching the recording, everything will be on Showcode's Discord. There'll be a Cudos section, channel, and all the documentation for Cosmosm, GitHub repos will all be on there for you to digest. And yeah, for later check-ins with the video, the recording will be on there as well.
Cool.
I guess on our side, thank you both for your time, and it was very thorough. And yeah, we'll look forward to Athena tomorrow, but also the blockchain program for Cudos that will be on Showcode. We'll be seeing you guys more.
Yeah.
Absolutely, looking forward to it, Rom. Yeah, thanks so much for having us here today, and thanks, Andrich, for the demo on that side. So yeah, we got to see that front end aspect and then the contract aspect, and then there will be a little bit of my assistance in putting them both together and being able to call the contract from a front end at the event itself. So we'll help out on that side there. But yeah, seriously looking forward to it. Keen to see y'all on tomorrow. And so I should be there relatively bright and early for both days myself. But yeah, thanks so much for having us, Rob.
Cheers. All right. Thank you.
Thanks.
Yeah. Bye.
Bye.
Wait. 1 second. Someone had a question.
Yeah.
Aha.
I saw that. Yeah. I think they're asking to speak.
Let's try.
Think there's now permission to speak for ACT Day.
Yeah.
Yeah. If you can't speak, you can also type your question in the chat. And yeah, I think they're asking permission again.
Yeah, I've given permission to present.
I think they can type their question in the chat. Akde. Okay, so they're typing in. Hi. Is there an internship program?
Oh, so that's actually a great question. So from the Cudos side, so Antrix here is one of our developer ambassadors. So while we don't have an internship program at the moment, we are also looking for additional dev ambassadors like Antrix here. So if you are interested in joining on that developer front, creating some content, there's some cool bounties and cool rewards there. And yeah, you get to work closely with us as well. In terms of providing training, yeah, so we have been running a Rust course that we are doing almost a trial run of. So we're happy to help with some Rust learnings there. And obviously we do support you the whole way through. But yeah, we want as many people to be part of the Rangers program, and as many people to also know Web3, know smart contract development, know front-end app development. So yeah, we're all for bringing people into the space. Antrix, your details there. Acte
we can connect on Discord. From there, I think we can talk. I'll just put in my Discord username in the chat. We can connect there, and then we can talk a bit on. We can connect one-on-one. You're learning Rust and DeFi. That's cool.
Nice one. Yeah, so yeah, definitely connect with Yum, and yeah, would be great if, especially if you're interested on that Rust and DeFi side, to have a look in terms of the ambassador side, and helping you to understand a bit more on it. But yeah, so as I say, I'll be there tomorrow as well to help, and to help with any connections you might want. But that's a great question in terms of the internship there.
Cool. I guess if there's no other questions, yeah, definitely tune into our Discord at Showcode and check the Cudos channel, and also, yeah, get ready to sign up to the Cudos program coming up soon in early November.
Cool.
Absolutely.
All right.
Thank you.
Thanks, everyone.
Thanks so much, all.
Cheers. Bye.
Bye.